Hello, good evening, everyone. Welcome back to my YouTube channel. I am Ganesan G, Assistant Professor in Computer Science Engineering, SNS College of Technology, Coimbatore. This video lecture series is developed for the subject code 23 ITB 201, the subject Design and Analysis of Algorithms for second year, fourth semester, Artificial Intelligence and Machine Learning, Computer Science Engineering, and Information Technology students. Today, in this session, we will learn one of the fundamental sorting algorithm, Heap Sort. Let's start the session now. Previous class, we have learned about the two types of searching algorithms. So one is linear searching, second one is binary searching. Linear search, just we want to find the particular element in a given array. We start the search from the first element, then we follow one by one up to the element what we want to find. So it takes long time to get the element because this search searches one by one in the sequential way. Second searching algorithm is a binary search, is better than a little better than the linear search because this searching technique sort the elements in either ascending order and descending order, then divide the array into two groups, compare the middle element with the which element we want to find. Then if the particular element is left side of the middle element, we search only the left side part. If suppose the middle element is greater than, if the finding element is greater than the middle element, we go for right side. So the entire array is subdivided into two parts. So this algorithm is better than linear search. In this session, we are going for sorting algorithms. We already know that sorting is the process of arranging the numbers or letters or any characters or any records into a specific format in a sequence. For example, in your classes, you are all are arranged by your naming order, the alphabetical order. Start from A, then B, C, D, like this. The register numbers also assigned for you to you based on your name in alphabetical letters. The same like we are arranging the numbers in either ascending or descending order. So sorting is the process of arranging any numbers or characters or any strings or any records in the databases into either ascending or descending order. There are so many ascending orders types are there: bubble sort, keep sort, quick sort, merge sort, selection sort, insertion sort. So each algorithm has its own time efficiency and space complexity. So we choose which sorting technique is most efficient in time complexity and space complexity. In this video series, we learned keep sort. So before that, what is meant by a keep? Keep is a data structure which look like a complete binary tree. We know that already. Binary tree means a node element having two child elements. Each element has maximum of two child elements. The left element is always greater than the right element is a binary tree, is the general rule for this. So keep sorting is also based on complete binary searching tree like this. So the given elements are arranged in the form of tree. Like example is given here. There are 12 elements are here. All 12 elements are arranged to form a tree-like structure. This tree is called as keep tree. There are two types of keep tree. One is a minimum keep tree. It's also called as min keep. Then second one is maximum keep tree. Is also called as max keep. What is the difference between this min keep and max keep? Based on the diagram given, the parent element is always greater than the child element is called as max keep. At the right side of the diagram, the root element is 100, then child element is 40 and 50, then child elements of 40 is 10 and 15, child element of 50 is 50 and 40. Here the parent of 10 and 15 is 40. So 40 is greater than 10 and 15. Then again 100 is greater than 40 and 50. So this is called as max keep. The root node is always greater than the child node. Vice versa, the parent node is always smaller than the child node is called as min keep. From the left side, diagram is given. So 40, 50, then the parent node is 15. Then again, the 15 and 30 is parent node is 10. So here, the parent node is always smaller than the child node. Understand? So min keep, the parent node is always smaller than the child node. Max keep, the parent node is always greater than the child node. This is general keep. What is the working principle of keep sorting? There are two types of steps, two steps also there for keep sorting algorithms. One is creation of keep tree, then processing of keep tree. There are two different stages. The first stage is a creation of keep tree. How to create a tree-like structure, the complete binary tree. So first to put the largest element on the top, that means it's a parent node, max keep like this. In each step, the size of the keep is increased. For example, first 10, there are 10 elements are given. We create the first element, then we add the next element to the left child of the tree. Then another element, the right child of the tree. By adding the child for the parent each time, we compare the element value with its parent node. If the parent node is smaller than the child node, we replace it. That means we replace the child node into parent node. So always we check the constraint. The parent node is always greater than the child node. If child node is smaller than the parent node is best. Then second stage, what is the processing of keep? So once the tree is created, we find the last left least element in the tree. Then we replace the least element with the top element of the tree. Top element means the top root element of the tree. We replace the top element with the most last element. Then again we check the constraint. We sorted the element. The rules are given already. The parent element is always greater than the child element. If the order is not corrected, then we will replace the child element with the parent element. We will check the order from root to leaf element. Again, the steps are repeatedly until all the elements are replaced. Here the elements are given, the array is there, 4, 1, 3, 2, 16, 9, 10, 14, 8, 7. These are the elements, given elements in the array. Our goal is to arrange these elements in ascending order or descending order. So we are arranging here in ascending order. So first element may be 1, 2, the result is 1, 2, 3, 4, 7, 8, 10, 14, 16 is the order like that. So what is the first element here? 4 is the first element. So we place the first element at the top here. Then we add 1 to the left of the 4 and 3 to the right of the 4. Then repeatedly we continue this process to fill all the elements in the boxes. Let me consider a simple example here. An array A consisting A is 5 elements 7, 4, 3, 1, 2. So the first element 7 is placed at first with the circlet. Then the second element 4 is always added left of the 7. Then the third element 3 to the right of the 7. Okay. So the first element is the root element. The next two elements are child of the first element. 4 and 3 are the child of 7. Again, fifth element is there, 1 is there. We go for 4 because Kip's tree is look like a complete binary tree. So all levels have only 2 elements. So again we place 1 to the left of the 4 and last 2 to the right of the 4. Understand once again, the place the first element 7, then second element to the left of 7, then third element to the right of 7. Then again 1 to the left of 4, then 2 to the right of 4. Understand? What will happen if another one element is there? Yes, correct. The element is added to the left of the 3, and one more element, if one more element is there, that element is placed to the right of 3. Understand? Right. It's a complete binary tree like structure. Then second stage, processing the elements. Here we are forming the keep structure 7, 4, 3, 1, 2. What is the first stage? We replace the last element with the root element. Okay, what is the last element here? 2 is the last node, leaf node. Here 2 is replaced with 7. So 7 is the most right part of the array. Then replaced with 2. Again check the constraints. So 2 is not smaller than 4. The again replace 4 with the 2. So now 4 is placed at top. Then 4, 2, 3, 1 is the second one. What the second step? Now we replace the last node 1 with the root node 4. So now 4 is replaced with the 1. So now the structure is 1, 2, 3. Again we check the rules. 1 is always smaller than 2. So we replace 2 instead of 1. Then again one more 3 is there. 3 is greater than 1 and 2. So we place 3 at the top. Then again the structure is 3, 2, 1. What is the least one? 2 is the least one. We replace the 1 with the 3. So place 3 at the array. Then now we will have 2 elements 1 and 2. So replace 2 because 2 is the greater than 1. So 2 is moved to top of the tree. That means the root node. Again we remove the top root element 2 to the array. Then last only one element is there, 1 is there. So finally we remove 1 and put it in the array. So now we will get the most ascending order 1, 2, 3, 4, 7. Understand? So this type of algorithm is called as keep sorting algorithms. There are 2 steps. First stage we create a tree. Then second stage, remove the last node of the tree with the root node. Again we maintain the maximum keepify structures. We will get the result. So that's all. End of this session, I will give you one problem for you. Sort the given elements 9, 4, 3, 8, 10 to 5 using Heap Sort algorithms in ascending order. Arrange the elements into ascending order. You will complete the session algorithm next classes. If you have any doubt on this topic, please refer the textbooks I have attached here. Introduction to the Design and Analysis of Algorithms by Pearson. And one more reference book is there. Data Structures and Algorithms Made Easy by Narasimha Karmanchi. That's all in this session. Thank you. Bye all. Take care. Good night.